Hello students, this is our second session or session 2 for acid, bases and salt. In the session 1 class, we have discussed about acid, properties of acid and types of acids. In this class, we will discuss about base, classification of base and indicators and some characteristics of acid and bases. So what is base or what are bases? Generally, we know that according to Arrhenius concept, the substances which produces OH minus ions, hydroxide ions in aqueous medium, that is in water medium, these are called base. Here, base means substances which produces OH minus ions in aqueous solution is called base. Example, NaOH aqueous. Aqueous means water. It will dissociate as Na plus aqueous OH minus aqueous. Say potassium hydroxide. Potassium hydroxide. Since it will dissolve, dissociate like this. So these are bases, the substances which produces hydroxide ion in aqueous solution is called bases. Example, sodium hydroxide, Na plus OH minus, potassium hydroxide, Ka plus OH minus. Since the sodium hydroxide and potassium hydroxide releases hydroxide ion in aqueous medium, so these are base. Not only these two, so many examples are there. Okay, now some bases. How will you know that these are base? Simple answer, which produces OH minus ions. Not only that, for this question we have to know some chemical properties of base. Later we will discuss about these. So these are base. Now some types of bases. All hydroxides are bases. That is, all metallic hydroxides are bases. Example, types of bases. Types of bases. All metallic hydroxides. Metallic hydroxides. Hydroxides are bases. Example, say sodium hydroxide. Sodium is metal. Potassium hydroxide. Potassium is metal. Then calcium hydroxide. Then aluminium hydroxide, etc. That is, all metallic hydroxides are bases. Number 1. Number 2, metallic oxides are bases. Base. Example: sodium oxide, base; potassium oxide, base; zinc oxide, base; calcium oxide, base, etc. The question: why metallic oxides are base? Metallic hydroxides are bases. It is very easy. Whenever you will dissolve this one in water medium, that is in aqueous medium, they will release hydroxide ion, so they will base. But why? How metallic oxides are base? Simple. Whenever you will dissolve these metallic oxides in water, they will form metallic hydroxide. Say for example, say sodium oxide, give water, it will form sodium hydroxide. Simple. So since sodium oxide when dissolved in water forms sodium hydroxide, so sodium oxide is base. Similarly, potassium oxide will form potassium hydroxide, zinc oxide will form zinc hydroxide, calcium oxide will form calcium hydroxide. So these are the some example or some types of bases. Okay. Now, out of these bases, some bases are soluble in water, some bases are insoluble in water. So we can classify them as water soluble bases, water insoluble bases. Okay, just remember one thing: any hydroxide ion, if made up of sodium any hydroxide which is made up of sodium, potassium, calcium, ammonium, these are some water soluble bases. Sodium means sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide. So all these are the water soluble bases. And remember one thing: the water soluble bases are known as alkali. If questions are coming like this, define alkali, give example. You will write the water soluble bases. The water soluble bases are called alkalis. Example: sodium hydroxide, potassium hydroxide, like this. Clear? And some bases are there which are insoluble in water. So some are soluble bases, some are insoluble bases. Insoluble bases, it may be copper hydroxide, insoluble base, aluminum hydroxide, insoluble base, etc. like this. So in CBSE, sometimes one questions are coming that all bases are all alkalis are bases, but all bases are not alkalis. all alkalis are bases, but all bases are not alkalis, justify. Then what will you do? First, you have to write the definition of alkalis. That is, we know that how will you write, okay? And you have to write to the point. You have to write to the point, okay? So how will you write? First, you will write the definition of alkali. Like that, we know that the water soluble bases are called alkalis. First line. Second line, some example. Let us give in some examples. The first line is the definition of alkalis. Second line, you have to take some examples. Say for example, some examples of bases: sodium hydroxide, potassium hydroxide, copper hydroxide, aluminum hydroxide. Okay, all these are bases. All these are bases. But out of these, it is water soluble. This is water soluble. This is also water soluble. Means these two are, this alkali, it is also alkali, but these are not water soluble. So how will you write? First definition, then you will write. Now let us take some examples of bases: sodium hydroxide, potassium hydroxide, copper hydroxide, aluminum hydroxide, etc. Out of these, all these are bases, but out of these, sodium hydroxide and potassium hydroxides are water soluble bases. So these are alkalis. But copper hydroxide and aluminum hydroxide are not water soluble. So these are only bases. Complete your answer. Clear? So all alkalis are bases, but all bases are not alkali. Clear? Now, so if any idea, if any doubt, you can comment me in the comment box. Clear? Next, we will discuss about some characteristics of base. Now, there are some characteristics of bases. Before that, two another types of bases are there. One is strong base, one is weak base. It depends upon the dissociation of base in aqueous medium. Like acid. Acids have also strong acid, weak acid, that is which completely dissociated. This is strong acid. Same, the bases which completely dissociated in aqueous medium, these are called strong base, and which are partially dissociated or it does not dissolve completely, it is weak base. So weak base, ammonium hydroxide, it is weak base. Sodium hydroxide, potassium hydroxide, etc. These are strong base. That is the bases which are soluble in water completely. This is strong base, and which are not soluble completely in aqueous medium. This is weak base. Okay. Now, another thing in the definition we told that the substances which dissociate in aqueous medium and forms hydroxide ion is called base. But just now we have seen that it is not necessary that hydroxide ion should present in the compound to form a base, like metallic oxide. Just now we have discussed metallic oxide. No hydroxide is there, OH minus ion is not there, but till you see it is base, because whenever metallic oxides are dissolved in water, we have seen already, it forms hydroxide ion. Clear? Okay. Now let's come to the characteristics of some bases. So in all the characteristics, all the properties in chemistry, there are two types of properties for all compounds. For all compounds, whenever you will study in class 11 or 12, we will see that for every compounds, there are two types of properties or characteristics. One is physical characteristics, another is chemical characteristics. So same thing in bases also, two types of characteristics are there. I have written at a time all. First one is physical characteristics, means bases are slippery like soap, and taste, it is bitter and very unpleasant taste. These are the physical character. Number two physical character, it changes the red litmus paper to blue, that is action on litmus paper. Action on litmus paper. Okay, that is litmus paper is an indicator. We will discuss this later. We have different types of indicators are there. So bases show different color in with different indicators. Okay, so one character I have written here, that a base can change the red litmus to blue. Chemical properties. A base reacts with an acid to produce salt and water, which is called neutralization reaction. Already we know about this from class 7. Neutralization reaction. Another chemical properties, a base can combine with carbon dioxide to produce a carbonate. Clear? A base can combine with carbon dioxide to produce a carbonate. Okay, so these are the some characteristics of bases. I am discussing about CBSE pattern. So in CBSE, if questions are coming like this, write the characteristics of base. Maximum 2 marks or 3 marks will be there, and here you have to write for 2 marks 2 point, 3 marks 3 point. No need to write more points. If characteristics of bases will come and 2 marks is there, try to write the chemical properties. Try to write the chemical properties. Okay, and if it is 5 marks, I am sure 5 marks question will not come. Okay, then you have to write everything, but for 2 marks you have to try to write the chemical properties. Clear? So these are the some characteristics of bases. Okay, see, if you want to write, then you can write also, or you can take the screenshot. Okay. Okay student, now indicator. We have discussed acid, its characteristics, that is characteristics points, and classification of acid. We have discussed base, points of characteristics of bases, and some types of bases. Now indicators. After that, after the discussion of indicator, we will discuss all the properties of acid and bases which are included in our CBSE syllabus along with salts. So let's start indicators. Indicators means the substances or the chemical substances, some natural substances also, which indicates the presence of acid and bases, because acids and bases are colorless. So by seeing acids and bases, we can't detect that this bottle contains acid, this bottle contains base. So for this identification, we have to use some indicators, that is, which indicates the presence of acid or bases by changing their own color or by changing their smell. Okay, so we have 3 types of indicators. One is natural indicators, Number 2 is olfactory indicators. Number 3 is synthetic indicators. Okay. So there is no space for synthetic indicator, that's why I have not written. After that I will show this one. The first one, natural indicators, which obtained from nature. There's so many natural indicators are there. We have written here 3: litmus solution, turmeric, red cabbage. All these are obtained from nature, living source. So litmus solution actually obtained from lichens, and in acids, blue litmus solution changes to red, and in base, red litmus solution changes to acid. Litmus exists in two forms. One is solution form, one is strip, that is paper forms. Okay, so we can use any one. So again I am telling, in acid, blue litmus changes to red color. It may be solution, it may be blue litmus strip. Or in base, red litmus changes to blue. Number 1. Number 2, turmeric. Its actual color is yellow, but in base it turns into red brown. But in acid it does not change its color. Okay, you have to know this one. Okay, red cabbage, it is another natural indicator. Its original color is purple, but in acid it turns into yellow. In base it turns into greenish. Clear? Again I am telling, litmus, in acid blue litmus red, and in base red litmus blue. Turmeric, actually yellow in color. In base it turns red brown. In acid it does not change. Red cabbage, it is originally purple color, and in acid it turns into yellow. In base it turns into greenish color. Okay. Now olfactory indicator. From the name we get some idea. Olfactory means smell related. Okay. It is used for the visually जो पर्सन है, जो विजुअली इम्पेयर्ड जो पर्सन है, उसके लिए ये यूज होते, क्योंकि वो तो देखते नहीं है. तो विजुअली इम्पेयर्ड पर्सन के लिए olfactory indicator means the substances which changes their smell in acids as well as in basic solution. The substances which changes their smell in acid or basic solutions, these are called olfactory indicators. Example: onion extract, vanilla, clove oil. Onion loses its smell in base, but does not change its smell in acid. Clear? Vanilla, its smell vanishes with base, but it does not vanish with acid. That is, in acid, it shows some characteristic smell. Here, onion also can change. That is, it loses smell. That is, does not show color in base, but it will show some characteristic. Show means it will give some characteristic smell. So actually, it will like this. It does not change. It loses its smell and but changes into characteristic smell in acid. Clear? Same vanilla also, its smell vanishes with base, but it does not vanish with acid. Means it will show some characteristic smell. Same for clove oil. Clove oil also show vanilla जैसा character clove oil भी दिखाएगा. Okay? Number 1, natural indicator. Number 2, artificial indicator. Number 3, synthetic indicator. We had different types of synthetic indicator: phenolphthalein, methyl orange, methylene blue, like this. Now, how they changes the color in acid and basic solution, I am showing this one now. Okay, now you can write this one. Okay, you can write. Okay, students, now see there are some synthetic indicators: phenolphthalein solution, methyl orange solution. Okay, all these are acids: dilute hydrochloric acid, sulfuric acid, nitric acid, acetic acid. You see, all these, in all these acids, phenolphthalein is colorless, means phenolphthalein does not show any color in acid solution, but in basic solution all these are changes to pink color. That is, phenolphthalein in basic solution forms pink color. Now come to the methyl orange. Methyl orange in acid solution, it shows pink color. Okay, but in basic solution it shows yellow color. So these two synthetic solutions, that is synthetic indicators, are included in your syllabus. So you can write this table, that is the solution of phenolphthalein and the solution of methyl orange, how they changes their color in acidic and basic solution. Okay. So students, we have seen today basic solution, some characteristics, point of base, and there some classification of base and indicators. Okay, that is how many types of indicators are there, how, what is their color, how they changes their color. Okay, now next date we will discuss about the characteristics of acid and bases. Okay, thank you.